All right, guys, let's talk about rational equations. We already talked about simplifying rationals, but today we're actually going to solve them with that equal sign between them. We're going to talk about two specific methods. The bigger method to know is probably method 2, using that LCD or least common denominator. That one's always going to work. We're going to talk about method 1 on this first problem, though. On method 1, we're going to actually use that cross multiplication to solve it. But the problem with using cross multiplication is the only time you can do it is if you have an actual proportion. To be a proportion, you have to have just a fraction on one side, and you have to have a fraction on the other side. That's the only time you can use cross multiplication. If there's anything else, so cross multiplication, just as a reminder, we have something called A times D equals B times C. Now, anytime you have something other than just a fraction equaling a fraction, say you have A over B equals C over D plus 3, you can no longer do cross multiplication, so then you'd have to use an LCD. So method 1 only works if you can reduce it down to just a fraction on one side and a fraction on the other side. Then we can do our cross multiplication. So let's talk about both these methods. Method 1, we're going to use on actually this first problem. You're going to note that problem number 2 is the exact same problem. We're going to use two methods to solve this one. So the first method we're going to use is we're going to notice that it does have a proportion. We have a fraction on the left side, we got a fraction on the right side. So this falls into the realm of we can actually use our cross multiplication. Cross multiplication says, well, we could take this top one and multiply it by that 4. We could take that 10 and multiply it by that v plus 4. What I typically do is I take that whole number. So I'm looking at that 4, and I'll multiply that by that v minus 4. Then we have that v plus 4 times 10, so I'll have 10 times the quantity v plus 4. We're always using parentheses if we have anything more than one term. So notice that v minus 4 and that v plus 4, when we do the multiplications, they have to be in parentheses. When we distribute both of these, we should end up with 4v minus 16 equals 10v plus 40. And now we just have a linear equation we're going to solve. Per my usual solving method, I like to keep my variables positive. So I'm going to subtract 4v from both sides. That will give me a negative 16 equals a 6v plus 40. Now I'm going to go ahead and subtract 40 from both sides. Minus 40. That's going to give me a negative 56 equals 6v. Now when I divide by 6, it's not going to go evenly. We're going to end up having, negative 56 divided by 6 equals v. We can simplify both these because 2 goes into 56, 2 goes into 6. So we're going to divide the top by 2, giving me a negative 28. We'll divide that 6 by 2, and we'll have 3. We have v equals a negative 28 over 3. That is when we use our cross multiplication because we have a proportion. Now, just because we have a proportion doesn't mean we have to use method 1. We can always use method 2. That's why I say it's the better one. It's a catch-all. It will always work. That is multiplying by the lowest common denominator or least common denominator, depending on what math book you're looking at. So our LCD has to be a number that both of our denominators go in. So I'm looking at that 10 and 4. I'm looking for a number that both 10 and 4 go into. Now, one of the easiest numbers that would go into both of those would be 20. Because 10 goes into 20, 4 goes into 20 as well. This would be our LCD. I do want to bring up the point that if I can't think of a number that 10 goes into and 4 goes into, you can always use, so note, you can always multiply your denominators. So we can always multiply our denominators. In this case, we could have used, we have a 4 and 10. We could have used 4 times 10, which equals 40. 40 would have worked. It wouldn't be our lowest common divisor, but it would be our, it would work. It's just one that's bigger, so I can multiply everything by 40 and it would work. 20 is going to be a little bit easier. So when we distribute this 20, it's actually just going to impact our denominators. Our goal is to actually get rid of the fractions. That is our whole goal. Get rid of the fractions so we can solve this like a normal linear. The long way around is to realize that. So when I distribute this 20, I'll have 20 times v minus 4 all over 10 is going to equal 20 v plus 4 over 4. Now, these 20 and 10 and this 20 and 4, we should be able to use those two things to get rid of our denominators, knowing that 20 divided by 10 will leave me with a 2. So we have 2v minus 4. Our 20 divided by 4 is going to be 5. So we're just going to have 5 times v plus 4. Do some distributing of 2v minus 8 equals 5v plus 4. I'm going to subtract both sides by that 2v, giving me negative 8 equals 3v plus 4. Subtract 4 from both sides. Well, before I subtract that 4 from both sides, we will note that I actually made a small little mistake. That we should have made sure we distributed this 5 to both things. I just did it to the v. So we should actually had 5v plus 20, just like we should have 3v plus 20 here. Now when we subtract our 20 from both sides, I'm going to have a negative 28 equals 3v. Divide both sides by 3, and we'll get v equals a negative 28 divided by 3. Should have the exact same answer, just two different methods. Once again, method 1 only works if you have a fraction equals a fraction. If you have anything else, we're going to use our LCD. So, looking at our next problem, it doesn't look like we have a fraction equaling a fraction. So this looks like a lowest common denominator type problem. So we need to multiply this by something that 4y, 4, 2y can all go into evenly. Well, just looking at the numbers, I'm just looking at the numbers in front, our constants, 4, 4, and 2. I'm going to notice the number that 4, 4, and 2 can all go into would be 4. Now we look at our variables. I got a y and a y. Well, they can both go into y. So 4y is going to be that number that all of them can go into. Now we're going to go ahead and we're going to distribute to everything, giving me 4y times y plus 1 all over 4y equals, here we'll have 4y divided by 4 plus 4y times y minus 2. Now we'll find things that cancel out. Well, that should be over 2y before I forget that. Now we're going to see things that cancel out. Well, we have that 4y divided by the 4y in that first thing. So on the left-hand side, we just have y plus 1. Our 4's will cancel out. That 4y divided by 4, the 4's will cancel out. I'm left with y plus, we'll notice that 4y divided by 2y, well, 4 divided by 2 is 2. The y's will cancel out. Our y's will straight up cancel out. These will turn into just 2. So we'll have 2 times y minus 2. Doing some simplification, we'll have y plus 1 equals y plus 2y minus 4. Let's combine those y's there. We'll have y plus 1 equals 3y minus 4. Once again, I do like to keep my variables positive, so I'm going to subtract y from both sides, giving me 1 equals 2y minus 4. Add 4 to both sides. I'm also going to continue this over here because I'm running out of room. Add 4 to both sides, and I should have a 5 on the left-hand side. Equals 2y. Divide both sides by 2, and you come up with y equals 2 divided by 5. For our next one, we have y divided by y minus 3 plus 3 equals 3 over y minus 3. Well, to get rid of our fractions, we need something that all of our denominators can go into. Well, it turns out all of our denominators are the same. I mean, I guess we have a 3 over 1, but 1 can go into anything. So I'm actually going to multiply everything by y minus 3, just by the only denominator we have, making sure we distribute to everything. Okay, that's going to give me, for our top one, we'll have y minus 3 times y over y minus 3 plus 3 times y minus 3. And then finally we have our y minus 3 times that 3 all over y minus 3. The nice thing is a whole bunch of these y minus 3's actually cancel out. So we have y minus 3 over y minus 3. That's gone. I'm left with y. Let's distribute that 3. 3 times y is 3y. 3 times a negative 3 is a negative 9. Once again, my y minus 3's cancel out. And I'm left with 3. Combine our like terms. I got a y, I got a 3y. That's going to give me 4y's. I'm going to add 9 to both sides, giving me this equals 12. So once again, I'm moving this 9 over here by adding 9 to both sides. Divide both sides by 4, and we have y equals 3. Fun, 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 except this is wrong. Well, it's not necessarily wrong. We did all of our work correct. This answer does not work. This answer doesn't work because I've been purposely missing a big instruction that we had up front. So let's go back to our very top of our sheet. It's bolded, it is capitalized, and it is going to be boxed in now. The denominator of an equation can never, ever be 0. What we should have done, if I front-loaded this question, is I would have noted to myself, we have one denominator that could possibly be 0. Since we have y minus 3 on a denominator, y minus 3 can never equal 0, because if that equals 0, our denominator is 0. Well, if y minus 3 can't be 0, that means y can never be 3. If you ever come up with y equaling 3, that's an extraneous solution. Y cannot be 3. I can't plug in the original equation because that would make the denominator 0. So although we came up with an answer of y equals 3, we'd have to be smart enough to know that that's an extraneous solution, and because that was the only possible answer and it doesn't work, there's actually no solution to this problem. So we're going to put no solution to it. So make sure when you start a rational problem, you understand in the very beginning there could be numbers that make this not work. If you looked at our first couple examples, so if I go back to this problem and I look at these denominators, I'm going to note that this denominator can't be 0, nor can this one be 0. Well, the only way to make those two 0 would be if y would equal 0, so y could not equal 0 in that case. If we go back to the other two, we don't have variables in the denominator, so whatever answer we get out works. So once again, if you have a variable in your denominator, you first have to ask yourself, what values would make it not work? So let's keep that in mind when we get to this problem. So when I look at this problem, I'm looking at my denominators right now. I'm looking at that x minus 1 and x plus 1. I'm also going to make a quick note to myself. I'm going to notice we have an x minus 1 and x plus 1. I also have an x squared minus 1. One of the key things to this problem is realizing, so let's put a little note here. If I ever see x squared minus 1, I should picture that as being x squared minus 1 squared. That is a difference of squares. Well, a difference of squares, x squared minus 1 squared, would equal x minus 1 times x plus 1. So what I want to note is when I come back to this equation, I see this x minus 1 and this x plus 1. Well, that's already covered by our difference of squares. So when I'm actually looking for a common denominator, or something that both x minus 1, x plus 1, and x squared minus 1 go into, I'm going to multiply everything by x minus 1 times x plus 1. Because that will, the x minus 1 will go into it, the x plus 1 will go into it, and so will that x squared minus 1 will also go into it. So I'm also going to really quickly note, if these are my denominators, and there's a variable in the denominator, that's going to lead me to say, oh, you know what? if I get answers of x equaling 1 or negative 1, it's not going to work because x cannot equal a negative 1 or a positive 1 because that'll make both those denominators 0. And noting that would be the same effect for that x squared minus 1 since it is composed of just x minus 1s and x plus 1s. All right, let's go ahead and distribute all this stuff. I'm going to go ahead and change that x squared minus 1 to x minus 1 plus x plus 1 in a second here. So for that first part, when I distribute, I'm going to have 2 times x minus 1 times x plus 1 all over x squared minus 1, which equals x minus 1 times x plus 1. That's going to equal our x minus 1 times x plus 1. As I distribute this here, I should probably note where I'm distributing it. All over x minus 1. And then finally, I'm going to distribute it to this equation here. So we have minus x minus 1, x plus 1, all over x plus 1. Now let's cancel out anything that's attached by multiplication. So we have this x minus 1 here. I got this x plus 1 here. So on the left-hand side, I just have a 2. Moving on, I do have this x minus 1 and this x minus 1 here, which will leave behind that x plus 1. And then finally, I'll have this x plus 1 and this x plus 1 and this x plus 1 are going to cancel out. I'm also going to note that this negative does need to be distributed to what's remaining. So instead of being x minus 1, I'm going to have a minus x plus 1. Now we'll continue on. We'll notice that, oh boy, that x there, that negative x there, those will actually cancel each other out. We'll have a plus 1, and we'll have a 2 equals 2. That is a true statement. If that's a true statement, that means there's going to be all solutions. So we could go over here and put all solutions. However, that's not entirely true. It's not all solutions because I got to bring in values where x doesn't work. So I can go all solutions, but x cannot be 1 or negative 1. So it'll be all solutions except x cannot be 1 or negative 1. You must note that. You must say all solutions except where x equals 1 or negative 1. In some way or fashion, you have to note that. Otherwise, you are incorrect. And the final problem. The final problem I'm looking at is this u cubed plus u squared, u plus 1, this u squared, all being on our denominator. Here's a little advice. If we have three things that are vastly different, because I have u cubed plus u squared, I got a u plus 1, I got a u squared, there's usually one that's comprised of the other two. Just like in this previous example, I had that x squared minus 1, which is comprised of x minus 1 times x plus 1. So what I would probably do is I would take the two smaller ones. So I'm looking at u squared, and I'm going to see what happens if I multiply that by that u plus 1. Well, if I distribute this, we're going to end up with u cubed plus u squared. So that means that u cubed plus u squared is really just comprised of u squared times u plus 1. So my common denominator is actually going to be the u squared times u plus 1, recognizing that this right here is the exact same thing as u squared times u plus 1. I guess we could have factored that out as well. I'm also going to note what values don't work. I'm going to say, okay, let's go through this, that u plus 1, I know u can't be a negative 1, because that would make that u plus 1 0. U squared, well, the only thing that would make that 0 is if u was 0. And if you look at, since u cubed plus u squared is just comprised of u squared and u plus 1, that negative 1 and 0 would both apply for that one. So we know that u cannot be negative 1 or 0 in this answer. Let's go ahead and distribute that u squared plus or times u plus 1. When I distribute it up here, we're going to have u squared times u plus 1. That's going to be all over that u cubed plus u squared, but I already said that's the same thing as u squared u plus 1. So that whole side is going to cancel out and turn to 1. Or not side, but part of that subtraction. Let's multiply it by that 1. We're going to have u squared times u plus 1 all over u plus 1. U plus 1's cancel out. I guess we can do this, and then we'll just handle that underneath it. And then finally, we have 3u squared times u plus 1 all over u squared. Our u squareds are going to cancel out. So our new equation is going to be, now be careful, this is not 0. This is 1. When the top and bottom cancel out, it turns into 1 over 1, or just 1. So we'll have 1 minus u squared is going to equal, let's distribute this 3 to that u and that 1, giving me 3u plus 3. Well, this looks like we're going to have at least 3 terms. I'm going to notice that 1 and that 3 will combine, so we are going to have 3 terms. We're going to have a u squared, a u, and we're going to have a constant. Now, I've said this before in previous lessons, I don't like a negative value in front of our term that's being squared. So I am going to subtract u squared to put it on this side. I am also going to subtract 1 from both sides. So that's going to leave me with 0 equals u squared plus that 3u, and then we'll have plus 2. I'm going to go ahead and box that in. I'm going to finish this over here. So currently we have 0 equals u squared plus 3u plus 2. I'm hoping this is factorable. Remember, I'm always looking for a 1 in front of that u squared to see if I can kind of use that quick guess and check method. Quick guess and check method, because it is u squared, it must be a u and u out front. There's only one way to make 2, and that is to make it 2 times 1. Well, it turns out 2 plus 1 also equals 3. So that gives us 2 possibilities. We have u can equal a negative 2. We can also have u equaling a negative 1. But I've already stated that u can't be negative 1, so that's not a possible answer. Instead, we just have u equals negative 2 as our solution. So the easiest way to do these is to recognize what your variable can't be before you begin. It makes it a lot easier than having to plug all of these in and check to see if they do in fact work. So I guess the moral of today's story is we have 2 methods. We can use that cross multiplication, or we can use an LCD. However, the most prevalent one is probably method 2, because it will always work. Proportions only work if you have a equal sign with 2 fractions next to it, and that's it. Anything else, and it doesn't work. So if you notice your problems 1, 2, looks like 3, 4, those can all be done by proportions, but if you want to, you can actually use the LCD. I know on a problem like 4, it's probably easier if you just use cross multiplication, but you could definitely use a lowest common denominator as well. All right, guys, that is our rational equations. Note we just have one more lesson. Then we'll have a quiz, a review day, and a test. I'm not sure what days those all fall on you. Make sure you stay up to date on your RangerNet to see what important days are coming up. All right, have a good one.